Okay, we are on to page 3, looking at questions 5 through 10, and tried to give you, so you didn't have to flip back and forth, a different table here, and some information that's going to come up in this one. This is not something you'll be tested on, but just kind of FYI, and you're going to see this throughout. There are different units for energy, and another unit of energy that you could hear is the calorie. Calorie is just, again, a unit of energy that most people use whenever we talk about processing food a lot of times. However, there is a little bit of a difference in that the food calories are represented with a capital C, and these are usually represented as kilocalories. So, for example, if something says that it has 200 calories, what it actually has is 200 kilocalories, which is actually 200,000 calories. And so I just kind of wanted to make that connection for you with biology that calorie is a unit of energy and that we can convert that into joules using the conversion factor 1 calorie equals 4.184 joules. So just trying to kind of get you to see this equation of specific heat and understand the different dimensions that are there to it. So in looking at the first one, it says an endothermic process. So when you see that word endothermic, we know that the Q is going to end up being positive here. It absorbs 138 kilojoules. How many calories of heat are absorbed? So here's where we're going to go ahead and use that conversion factor. We are trying to convert that into calories here, but right now it's in kilojoules. So we've actually got to make two conversions here. We're going to start by writing 138.0 kilojoules. And think back to dimensional analysis. We're going to write down where we're starting and what are we trying to get to. We're trying to get to calories of heat. Well, before we can get to calories of heat, we've got to convert this into joules. So we know that 1 kilojoule represents 1,000 joules. And again, that's just understanding that prefix of kilo means 1,000. And then now we've got to go from joules to calorie, which we can do using this conversion factor of 4.184 joules represents 1 calorie. And then we'd multiply straight across 138 times 1,000 divided by 4.184. And when you put that into your calculator, what you're going to get out is 32,982.79, and that's calories. Okay. Now remember to look at your original number. We've got 4 significant figures here, which means our final answer needs to also have 4 significant figures. So I kind of like to give myself a visual. These are the 4 that I want to end up being significant, which means is that 2 going to make the 8 stay the same or go up? And we know that it's going to make it stay the same. So our final answer here would be 32,980 calories. 4 sig figs, and we've gone from kilojoules to calories. Again, nothing to do with specific heat there, just understanding a little bit of dimensional analysis and that endothermic and what that means as far as being positive. And here we have an exothermic reaction. So again, when you see that word exothermic, you should be thinking of a negative Q because energy is being lost. It releases 325,000 calories. Convert that into kilojoules. So this time we're going to go the opposite way. We're writing down a negative 325,000 calories, and we are going to convert this into kilojoules, so the opposite of what we just did. Look back up here to your conversion factor. We know that 1 calorie represents 4.184 joules. And now we're going to go from joules into kilojoules, and we know that 1,000 joules represents 1 kilojoule. So you're going to multiply straight across negative 325,000 times 4.184 divided by 1,000, and we would get 1,359.8 kilojoules. Again, keep in mind that that's negative because heat's getting lost as far as Q goes. Sig figs. 3 significant figures, which means we need 3 significant figures, so we're going to focus in on these. Is that 9 going to make the 5 go up or stay the same? It's going to make it go up, so this is going to end up being 136,000 kilojoules are what are lost. So if you want to put that negative there to kind of indicate that that's what is lost in the reaction, you could always do that. Okay, so again, just something different there, looking at dimensional analysis and how it can relate to other units of measurement. Let's go ahead now and jump back into specific heat. It says how much heat in joules is absorbed by 32 grams of water as it is heated from 25 to 80. So again, if you're having trouble right now at this point, I would go ahead and identify that this right here is my final temperature. This right here is my initial temperature. This right here is my mass, and I'm looking for Q, which means the only thing that I'm missing is CP, and it tells me here that we are looking at water. It's from 25 to 80, which means it's liquid water. And if you look up here at your table, we've been given 4.184 joules per gram degrees Celsius. So let's go ahead and fill in what we know. Q is what we're looking for, 32.0 grams times 4.184 times 80 minus 25 is going to give us 55 degrees Celsius. And when you put all of that into your calculator, you get a rather large number, 7,363.84. And that is in joules, and it is positive because it says absorbed and because our value came out positive. Let's look at sig figs. 3 sig figs here, 3 here, 3 here. So let's get this to 3, which means our answer would be 7,360 joules of heat is absorbed in this reaction. Okay, and kind of the same thing that we were looking at earlier. It says, what is this energy in calories? So this is a one step. We've already got it into joules, so 7,360 joules, and we're going to convert that into calories. We know that 1 calorie represents 4.184 joules, and then when you do that division, we end up with 1,760 calories. So just a little bit of dimensional analysis there again, looking at those different units and how we can go between them. Number 8, how many kilojoules of heat? And I tried to kind of bold things. This is where, we've been just plugging numbers into an equation, so now we're really looking at some unit conversions here. How many kilojoules of heat are absorbed, so we know it's going to be positive, when 1 liter of water is heated from 18 to 85. So let's kind of identify what we do know. We know it's water, which means the specific heat here is going to be 4.184. We know that it's heated from 18 to 85, which means that would be 67 degrees Celsius as far as the delta T goes. And right here is really our mass. And you're thinking, Ms. Vaughn, that says liters, and liters is volume. But look right over here at the hint you were given. 1 milliliter of water equals 1 gram of water. So let's go ahead and work through that conversion. 1 liter, and we're trying to get to grams of water, where I know that 1 liter has 1,000 milliliters. And this conversion right here tells me that 1 milliliter is equal to 1 gram. So ultimately, I have 1,000 grams of water. Okay, so that right there is my mass that I was needing. And now let's go ahead and plug that into our equation. So we've got 1,000 grams times 4.184 times 67 degrees Celsius. And when you put that into your calculator, you are going to get, again, a rather large number. And that would be 280,328. And that is in joules. Now, before I look at sig figs, I'm going to go ahead and make a note. This was in kilojoules. Well, if this is joules and we're trying to go to kilojoules, you're going to move your decimal 1, 2, 3 places to the left. So this is actually 280 decimal 328 kilojoules. Now, let's take a look at significant figures. 2 sig figs, 2 sig figs, 3 sig figs, which means my answer needs to be in 2 significant figures. So I'm just actually going to drop everything over here, and this is going to end up being 280 kilojoules as my final answer. Okay, moving on. 2 more. How many joules of heat are lost? Okay, so again, this automatically tells me I'm going to end up with a negative Q. Here's that mass of granite, and if you look back up here, I see that the granite is 0.803, but again, know that that's in grams, which means my mass needs to be in grams. So we are going to do a little bit of movement there. So the granite was 0.803, and it cools from 41.2 to negative 12.9, which I believe is a negative 54.1 degrees Celsius. There's that delta T. Now, before I can use this value right here, I've got to change my mass into grams, which is going to end up being a rather large number because this is in kilograms. So let me go ahead and move that decimal 3 places to the right. Make sure I don't mess this up. I'm very visual. 1, 2, 3. So that would be 3,580,000 grams. So here we go. Q equals 3,580,000 grams times specific heat is 0.803 times negative 54.1. And let's go ahead and put that into our calculator. And I'm getting a rather large number. That's okay, we would expect that because of that mass here. It's going to be negative 1. Big number, okay? And again, that would be in joules. So our answer wants this in joules. Let's go back and look at sig figs, 3 sig figs, 3 sig figs, 3 sig figs. So we're going to end up rounding this right here. So that would be negative 156. You could always go through and put it in scientific notation. That would be 1, 2, 3, 4, 5, 6, 7, 8. Negative 1.56 times 10 to the 8th joules. So either one of those answers would be correct. And again, remember that it's an exothermic reaction because we see that negative value for Q. Last one on this page, guys. How much heat is absorbed? So right off the bat, I know that this is an endothermic reaction. It is a 2,000 kilogram boulder. This is pretty big. And excuse me, it's granite. So same thing, 0.803. But remember that that value is with grams, which means once again, I'm going to have to change this into grams. And it tells me the temperature change is from 10 to 29. So I'm looking at a positive 19 degrees Celsius temperature change there. Let's go ahead and deal with this 2,000 kilograms. And let's turn that into grams, which means my decimal is going to move 3 places to the right. So it's going to end up being 2 million. Yeah, 2 million grams. Wow. Here we go. Q equals 2 million grams times the specific heat is 0.803 times the temperature change is 19 degrees Celsius. And let's go ahead and put that in our calculator. And we would expect a large number because of that mass. Like 30,514,000, and that is joules, and we would expect it to be positive because it did tell us that it was absorbed. If you'll note over here, the temperature change is what is determining whether or not something is negative or positive. So if the final temperature is higher than the initial temperature, it's an endothermic reaction, energy is being absorbed. If the final temperature is lower than the initial temperature, that's when we're getting these negative values in those exothermic reactions. Let's look back at sig figs, 4 sig figs, 3 sig figs, 3 sig figs. So we're looking for 3 sig figs here. So these is where we want to round to. So end up being 30,500,000 joules. Or you could write that as 3.05 times 10 to the 1, 2, 3, 4, 5, 6, 7. And that would still be in joules. So either one of those answers would be correct. Okay, guys, one more page and we are done.